So now that I've calculated the total plastic strain, what I've called the effective total plastic strain, I want to compare it with that output PEEQ that I had written into the file. So I'm going to clear the contents here. I'm going to pick up this PEEQ and plot it, place it right next to my total plastic strain. I'll make some room for it. I'll bring in this PEQ that we had saved from the output. And there I'm sticking in PEEQ. And you can see that the numbers that I'm getting for the total plastic strain and the PEEQ are all identical. Take a look at it. I can probably write this out in the same format. And then it'll be easier to compare. That's the total plastic strain that we calculated, and that's the PEQ value. And what I'm trying to show you is that they are identical. The PEQ values that have been output by Abacus are identical to the total plastic strain values that we calculated. But how did we calculate this total plastic strain value? In order to do that, we had to first calculate DEP effective, and that effective plastic strain was actually 2/3 times DEP11 squared plus DEP22 squared plus DEP33 squared, the whole square root. But in order to do that, we had to calculate DEP33, which we use the principle of no volumetric dilation to calculate. So this is great news. Now we know that when Abacus is telling us PEQ, what it means is the total or the lumped or the effective plastic strain at that material point. And when I ask it for the von Mises stress, it's telling me the calculated square root of 3J2. So those are the two numbers that it is calculating. And if I were to plot this von Mises stress versus the PEEQ value, what do you think I'm going to get? I'm going to get the effective stress versus effective strain curve that has been obtained from this, from that the material point has been following. So let's take a look at that. This is plotting the effective stress versus effective strain. Let's see what that looks like. Well, it'll look exactly the way we've input the data. It is an elastic, perfectly plastic curve, as one would expect. I just need to switch the values. V needs to become W and W needs to become V, so that we can look at this effective, perfectly plastic curve. Let's take a look. And what do we have here? That is the effective plastic strain. Where did it go? There it is. That's the effective stress versus effective plastic strain. And what does it look like? It looks exactly like the perfectly plastic stress strain curve that we've input. This is very important because that material point is always on the same effective stress total plastic strain curve. And that was the lesson that I was trying to get to. And in order to do that, we had to save all kinds of data and come around and look at the Prandtl-Royce relations. I'm going to continue this in the next video in a few minutes.